So this is the first problem. So basically a magnetic field has the vector field as follows. B equals 10yi plus 2y in the j direction minus mz in the k direction. And basically we need to find out what m is. So for this problem, let me just rewrite this here. B direction 10yi plus 2yj minus mz. Okay, awesome. So we're trying to find this m. So first, we're going to calculate the divergence using Maxwell's equation. Divergence of B. That equation should be set to, the expression should be set to 0. So basically the equation is this. It's a long one. Okay, divergence of V is equal to partial over xi plus partial of yk plus partial. It's supposed to be like that, but like for some reason they come out as 2's for me. C of j times v1 of I plus v2 of j plus v3k. Awesome. So what we're going to do now is plug in this to that equation. So what we're going to be doing is doing the divergence of V, which is doing the partial of 10y. The I direction is the partial of, make it like a d then, dy of 2yj, and the partial of c of mz. Okay, and it's all supposed to be equal to 0. So once we take the partial, there is no x, so this is going to be 0. Plus, so taking the partial of 2yj is just going to be 2, because taking the partial of y is just 1. And then same scenario here. So once we take the partial of z in respects to mzk, you just get m. So this is just a simple now equation that we're solving for m. So you basically do the simple math of just moving that m over, and we get m equals 2. And that's really it. The tough part is just the equation part, but once you plug that in, it's really basic and easy. Awesome. So now the second problem. So for this circuit, it's basically saying to find the power absorbed by the dependent source. So what I would do first, make it purple, I like purple. We're going to do KVL in this direction. All right, so we're going to start with positive 150 volts minus 20 volts plus make sure you get the 0.8 Vx. So this is our voltages, which is going to be equal to our current times the resistance here in the circuit, which is going to be the 10 and the 50. So first, we kind of have this Vx here that's kind of already given to us in a way. So what I'm going to do is I'm going to plug in for Vx, literally just 50 times I. That's what Vx would be. So I'm going to rewrite this as 150 volts minus 20 V plus 0.8 times 50 I. And then we can just simplify this and just put 60. All right. So now we just combine. Use the red. So we're going to combine this together. This is already combined our resistance. And then we're going to move this over to here. So I kind of like to do this in one step, but I guess I'll do it in 2 steps just so it's easier to see. So 130 volts plus 0.8 50I is equal to I 60. So now 0.8 times 40. I think that, yeah, this is 40. So we're going to subtract 40 here. And then we're given 130 volts is equal to 20 resistance times I. So basically now we're just solve for the current I. This is obviously the first step before we get to the power part. But so basically you do division, so it's 130 divided by the 20 resistance. And this should give you 6.5 amps. Now, so for the power, given the equation IV. For this case, because the source is absorbing the power, it's actually going to be negative IV. So let's just plug that in. So we're going to get the negative point Vx times the 6.5 amps. All right. For this case, now that we kind of solve what I is, now we can just substitute the Vx for the value that it should be. So negative 0.8, we said that, where is it? Vx is going to be equal to 50 I. Now that we solve for I, we're just going to plug that in. So we're going to get 0.8 times 50 times 6.5. And then again, multiply the 6.5 amp. And then once you plug that into your calculator, you should get 1690. And then since it's power, the unit is watt. So, oh, don't forget the negative. Don't forget the negative, very important. But yeah, those are the two problems that I have for you guys.